Here we follow step by step the reasoning to build the body of a function that deeply copies any reference. Let's imagine an object as input because that's where our reasoning will start. I initialize a new object and use object.keys to loop dynamically through each property of the parameter onto the new object. This loop, unlike the for loop, has a more concise syntax and works directly on the new object's own properties, skipping the prototype, which we are not interested in. Once the loop finishes, I return the new object. In this first step, I've achieved the same thing I would with a simple spread operator, being able to copy only an object without any other references inside. So what if one of these keys has another object as its value? I'm sure that the function calls itself, making it recursive. This way, if one of these keys contains an object, we could reproduce the keys of the internal object in turn. Clearly, however, I need to divide the cases. I want to do this only if the key I passed as a parameter contained an object. If it were a primitive instead, I would simply return it, thus avoiding an infinite loop by providing a termination condition for recursion. The parameter from obj becomes p, because at this point of the reasoning, as I said, it could be anything. Here we have a situation where what seems like a theoretical irrelevant trifle becomes influential in practice. When JS was invented, null was thought of as a not-filled memory address designated for an object. For this reason, if a key corresponded to a null, we will mistakenly enter here. But theoretically, null is still a primitive, even though JS recognizes its type as an object. Therefore, I add another condition in the if to let a null be returned and not enter the if. Then we add a check, array to understand if p at this level is an array. In this case, we simply return a new array mapping each of its elements as itself. Even the array, though, could have other references inside. Therefore, we map the element recursively passed to deep copy to cover all cases. Lastly, we check for every level at which a function should appear in the nesting. If it's a function, we will access its bind method and pass it a new empty object to bind the new function to a new memory address. This way, its this will point to the new object. Now we have deeply copied any type of data at any level of nesting it might appear.